There is so much buzz around agents, agent frameworks, end-to-end agentic applications, agent runtime, and every enterprise is in the agentic AI journey. This video is focused on grounding our understanding on all these concepts, from what is an agent, what are the different components of an agent, how do you build an agent using an agentic framework, what are the different agentic frameworks that are available. And once you've built your agent, how do you take your agent and productionize it for agentic runtime? So at the end of this video, you will have a good understanding of all these different concepts. In the subsequent videos, we will dive into much more details about building agents using a few frameworks. We'll see some code snippets, and also we'll look at how to deploy this agent for production, and we'll again see some code snippets in those videos. My name is Meena. I am a solutions architect focused on Gen AI development, and I work for AWS. Let's look at the scenario prior to November 2022. Almost every enterprise were building applications. These applications are differentiated applications built on data assets and tools and APIs that focuses on their business logic. So your data and resources could be structured data, which is in SQL databases, or unstructured data lying around in SharePoint sites to Confluence and so on. And your tools and APIs, think of it as your business logic that you write in some sort of code, right? So when we were building applications, we pretty much depended on these two capabilities to build differentiated applications, and every enterprise was doing this. Then in November 2022, ChatGPT was released, and this led to the large language model evaluation. So what did all these enterprises do? So they said, okay, we're going to start using large language model to build Gen AI applications. And most of these Gen AI applications were focused on summarization, extracting information from your data assets, and so on. So clearly, there was a bit of a gap between building Gen AI applications using large language models and using your enterprise differentiators. So there was a need for us to bring these two components together, your large language model and enterprise differentiators, which is how do I take my data, my tools and APIs and integrate it with the large language model so I can build differentiated Gen AI applications that is focused on my business. This led to multiple architecture patterns. One of the architecture pattern is retrieval augmented generation. Retrieval augmented generation is a way through which you take your enterprise data and integrate it with your large language model to build your differentiated app. Simply put, retrieval augmented generation, or RAG, means a question comes to your application. Application redirects the question to your data sources. This data source could be your structured data or unstructured data. Extracts or retrieves the information from the data sources, which is where the R comes in. Augments this data to your large language model, which is the A, and now the large language model starts to generate information. So this is how you brought your enterprise data to your large language model, rather than the large language model providing some ad hoc answers. And there are other patterns like fine tuning through which you can bring your data to your large language model. But then your tools and APIs were left alone. And this led to the next pattern, which is called as augmented LLM. To the large language model, you tell the model that these are all the tools and APIs that I have access to. And now when the query comes, the large language model, depending upon the query, looks at which tool is best suited to answer this question, and it provides the tool name. And then you can use the tool name and query the tool to do the work. right? So two of the patterns that emerged were, the RAG and fine tuning and the augmented LLM, which helps you to bridge the gap between your enterprise differentiators and large language model. Things were looking very good, and most part of 2023 and early part of 2024, a lot of the enterprises focus their energy on building RAG-based applications or augmented LLM-based applications. But all of these applications demanded you to create a predefined workflow, meaning for any question that comes to your GenAI application, you follow a defined sequence of steps. Let's take RAG as an example. Step 1, go to your data, get the information, retrieve the information. Step 2, augment it to your large language model. Step 3, generate. It does not really matter what kind of questions comes to your GenAI application. These are the only steps that will be followed to solve the problem statement. But in the real world, this is not the scenario. The questions could be different, and so your workflows could be dependent on the questions that are getting asked. So this led to agents. Before we jump into an AI agent, let's understand agents, what agents in real life do. We deal with agents in our real life most of the time. Let's take one such agent, which is a real estate agent. You could ask multiple questions to the real estate agent, and let's take two questions in this case to gain an understanding. Question number one is, you are looking at finding a house for yourself in a particular area within a particular budget. Now you go to your real estate agent and you tell the real estate agent, hey, this is my criteria. Go find me some options. So the agent now looks at the data that is at their disposal, which is house listings, which could be in some database, right? So they have a database of house listings that they have access to. They go query for information, then use some tools, some softwares that they have available for them, and build some sort of a representation of, all the house listings, the pros and cons, and so on and so forth, and provide it back to you. So in this scenario, the agent first went to the data that they had access to, and then went to some tools that they had access to give you the information. Now let's look at a second question. Now you've actually identified a house that you really liked out of the listings that came out. Now you go back to the agent and say you want to put an offer. In this case, the agent now has to go use some tools to look at some mortgage calculations for you, right? So option number one, put down 10%, option number two, put down 20%. So this agent is actually working with a set of tools that they have available with them to come up with some options and possibly refer to some data with some data resources that they might have, right? And then come back to you with, these are your options, and then you can go ahead and purchase this house. So in these two questions, in the first question, the agent went to the data and then to the tools. In the second question, they went to some tools and then referred to some data as they were building some scenarios for you. So depending upon the question, the real estate agent determines a dynamic workflow in terms of which data to access to, which tools to use to come up with an answer. Now let's come to AI agents. This is exactly what an AI agent is supposed to do. So instead of using a predefined workflow like a RAG or an augmented LLM in the previous scenario, the agent dynamically defines a workflow based on the question that comes from the user and then acts on the question based on the dynamic workflow. So how does the agent define a dynamic workflow? The agent takes the question, sends it to a large language model. So the agent has a large language model provided to it. It sends the question to the large language model. The purpose of the large language model is to understand the question, dissect the question, come up with the sequence of steps that needs to be done to address the user questions. Then the agent is provided with a set of tools and resources, and based on the sequence of steps that the LLM provided to the agent, now the agent is going to act on these questions, and it might use the data or the tools to act on it. So at a very high level, an agent needs a large language model to think and reason out what to do with the question, and then a set of tools and resources at its disposal to act on it to provide an answer. So 3 things at a bare minimum is required for an agent: a large language model, resources or data, and tools or APIs. Another key component that is required for an agent is instructions. Agent needs to have a defined scope. Let's go back to the example of real estate agent. We specifically called it as a real estate agent because this agent has a scope of working within the real estate domain. You wouldn't go and ask the real estate agent about your tax information or any other insurance information and so on and so forth. There are insurance agents and tax agents for it. So when you define an AI agent, it is really important for you to say this AI agent's specific purpose is to work in this particular domain. And the tools and the data that you provide to the agent are focused on those domains, right? So a real estate agent is provided with tools and data which is relevant to house listings, to mortgage calculations, and so on and so forth. So when you define an agent, the first thing is you define what are my agent instructions or what is the scope of my agent. Number 2, give it a large language model to do its thinking, to understand the question and decipher the question. 3, provide the agent with a set of tools and resources that the agent can act on. So just with 4 components, you could pretty much build an agent today. And even better, with less than 10 lines of code in any framework, you can actually build an agent today with these 4 different components. But that's all great as long as you're doing a proof of concept in building an agent. The moment you want to start thinking about taking this proof of concept into a prototype, you need to think about some additional capabilities for the agent. The first one is guardrails, right? So agent has a defined scope, tools, large language models and everything, but you cannot control the questions that comes to the agent. So you need a set of guardrails that helps you protect the agent from unwanted or unwarranted questions, like questions about violence, hate, questions that does not lie within the domain of the agent. All these things needs to be taken out of the agent's purview. This is where guardrails comes into play. And you need to think about how to define a guardrail. What are all the different components of the guardrail to make sure that the agent works and does the work it's intended to do. The second thing is memory. We always have multiple conversations with the agent. And as a part of these conversations, the questions that we are asking is dependent on the context that was provided to the agent in a previous conversation. So in this case, the AI agent needs to store all these conversation memory, history, and so on and so forth in some place. And that's where memory comes into play. Right? So now you need to think about what kind of memory management do I need to provide for my agent. This memory management could be a DynamoDB table, or it could be your SQL database or a vector database. There are multiple options for you, but you need to think about, how do I ensure that my agent has both short-term and long-term memory associated with it when it actually acts on it. The next thing is traces and spans, not scans, right? Spans. So the agent in itself is very probabilistic in nature. The question comes, the agent defines a dynamic workflow. Is this the right dynamic workflow? We don't know. Is it using the right tools and data? We don't know, right? So all of these things needs to be observed. And hence you need to build some level of an observability around your agents. This is where for every session, there are multiple traces, and for every traces, there are multiple spans, and for every spans, there are a set of calls that are happening. So you need to make sure that all of these things are observable and you have an observability tooling associated to your agent. And now you extend your observability to start evaluating if the agent is actually doing the right things. Now, in the proof of concept side of things, we said, we just need 4 components: the large language model, the scope of the agent, the tools and resources. Now, as we start to move away from proof of concept into a prototype, now we are starting to think about guardrails, memory management, observability, and evals, right? Your scope of your agent or the components that are required for agent has increased now. So now let's put all of these things together. So these are all the different components that are required to build an agent for you. So you need some sort of a framework to bring all these different components together. And that framework is called as an agentic framework. Think of agentic framework as a capability through which you can actually bring all the different facets of or the different capabilities of agent to work in cohesion. There are multiple types of agentic frameworks that are available. At a very high level, we divide it into 2. Number 1 is a managed framework. Number 2 is an open source framework. First of all, let's figure out what is the difference between a managed and an open source. When it comes to managed framework, the focus of the managed framework is to eliminate you from worrying about all the components like memory, guardrails, observability, and evals, and keep your focus on the core components of the agent, which is the large language model, resources, tools, and instructions, right? So when you're using a managed framework, your focus is building the core components of the agent, while the rest of the components like the observability, evals, memory, guardrails are all taken care of by the managed services by itself, right? So this is where Bedrock comes into play. Bedrock has a capability to build agents and they call it Bedrock agents. And using when you use Bedrock agents, you're focused on, again, the core components, while the rest of the things are provided by Bedrock, which is the undifferentiated heavy lifting that AWS provides through Bedrock. On the other hand, you have open source frameworks, and there are multiple open source frameworks available, probably hundreds by now, right? And some of the most famous ones include Strands from AWS, there is LangGraph, Llama Index, Crew.ai, Autogen, Semantic Kernel, and the list goes on and on, right? And when you're thinking about open source frameworks, it provides you the flexibility, right? So now you have utmost flexibility into designing each of these different components by yourself, right? So, but now you're focused on all the different components of building an agent, and there is nothing managed about it. So this is where agentic frameworks comes into play. Okay. Now we know that we can build an agent using one of these agentic frameworks that are available. Now once you're past your proof of concept to prototype, now you want to start putting it into production. This is where you need to have some sort of an agentic runtime where you can take these agents that were built and deploy it for production at scale. There are multiple ways for you to deploy agents into production. Obviously, you could use EC2 and spin off an EC2, deploy an agent, build all the dependencies and so on and so forth, and you can run your agent there. Or you could use Lambda functions, and there are obviously time duration of a Lambda, the memories of the Lambda. There are multiple things that you need to be worried about, but you could still deploy an agent using Lambda or EKS, ECS if you choose to do so. Or you could use one of the managed services that AWS provides, which is called as AgentCore. Okay, so this AgentCore was released in July 16th this year at the New York Summit. Right, so AgentCore is a capability that helps you to take your agent and run it in production at scale. The remaining set of slides, we will dive into what is AgentCore, what are the different components of the AgentCore, and what are the value proposition or the differentiators that AgentCore provides to you. Now that you have built your agent, imagine you've used any framework, it doesn't matter. Google's ADK, Microsoft Semantic Kernel, AWS's Trans, or even Bedrock or Crew.ai, it doesn't really matter. You can build your agent in any framework. Now you have to take this agent and deploy it in production. This is where the first component of AgentCore comes into play, which is called as AgentCore Runtime. What does AgentCore Runtime do? You provide your agent code to AgentCore Runtime or AgentCore. It packages your agent, makes it deployable application, and puts it into a runtime for you. And why is this important? This runtime is a managed runtime. It is serverless in nature, and you pay for what you use. Right? So even though the runtime is up and running, you only pay when the invocation basically happens. It is auto scalable, right? So all of a sudden, the last mile of you trying to package this agent, running it at scale, figuring out how many calls are coming to the agent, everything is resolved. Basically, AgentCore helps you to package it and deploy it at scale at runtime using AgentCore Runtime. Obviously, not just one agent and one framework. Any agent, now any number of agents, any number of frameworks, you can now start to put it into AgentCore Runtime. And you have multi-agents running in AgentCore Runtime, and each of these agents can talk to one another using any protocols from HTTP to MCP to ATA protocols. Right. So this is the first component of AgentCore, which is AgentCore Runtime. So when the agent is running in production, you need to have an observability capability. Whatever calls that are coming to the agent, everything needs to be metered, logged, and have a clear view of what traces, spans, everything that happens within the agent needs to be logged. And this is where the second component, which is AgentCore observability, comes into play. It's OTel compatible, and you can extend it using open inference. So you just, by default, when you deploy it on AgentCore Runtime, observability comes packaged in. And you do not have to write even a single line of code. Every call that comes to the agent gets observed, and all of these things are available in CloudWatch. You can go to, there is a new tab called as GenA observability within CloudWatch. You can log in there. You can see all the logs in there. If you choose to take this log and move it to some other third-party provider, like let's say a Langfuse or a Phoenix, you could pretty much take, because it is OTel compatible, you can use that in there. And it is extensible, meaning, if you are thinking about using any kind of semantic models that are defined in open inference, you can use it, start using some decorators in your code, and start writing your custom code to meet the additional capabilities of the agents that needs to be observed. The third component is AgentCore identity. There are multiple agents running within your agent runtime. You need an identity for each of the agent. And that's where AgentCore identity comes to play. At a very high level, think about some sort of an agent registry within the AgentCore identity, which has every agent listed with their IDs, their purpose, and so on. In addition, every agent requires some level of authentication and authorization. So who can access this agent? When the user accesses this agent, can this agent access these tools and resources and so on? So there is multi-level authentication and authorization that is required when you access these agents. And all of these OAuth can be configured within AgentCore identity. And we'll dive into much more details into AgentCore identity in the subsequent videos. But for now, think about it, it provides a repo of all sorts of OAuth things and a registry of all agents that are running. So that's where AgentCore identity comes into play. Then the next one is called AgentCore Gateway. So we said that when we build an agent, you're going to associate your enterprise differentiators, which is tools and data. You do not have one way to define your APIs or your tools or data, right? So you might have defined a Lambda function. You might have defined an API. You might have defined your own custom logic and so on and so forth. So imagine If you're exposing all these different tools to your agent, the level of customizable code that you need to write for your agents to access these tools. What if there is a gateway, a single gateway that is provided to an agent where the agent uses this gateway and accesses this tool using a very standardized format, which is your MCP format. And that is where AgentCore Gateway comes into play. I'll tell you how it works in 3 simple steps. The first step is you create a gateway. Second step is for all the tools that your agent needs to access, you register those tools to the gateway. What the gateway does is as soon as you register the tool, be it a Lambda function, be it your custom code and so on and so forth, it creates an MCP server underneath and makes it and exposes that MCP server to your agent. And step number 3, tell your agent that this is the gateway that you need to connect to, and the list of tools and the MCP servers are within the gateway. In just 3 simple steps, without going through your, converting your entire tool base into MCP enablement and so on and so forth. You just register these tools and your AgentCore Gateway does the rest of heavy lifting for you. And the final component is AgentCore memory. As I said, memory is very important when you are thinking about multi-turn conversations and so on. And within memory, there is a short-term memory and a long-term memory. Short-term memory is session-based. As you're when the user is within a particular session talking to the agent, there are multiple conversations. You just keep on storing these conversations in the short-term memory. And when the agent wants to refer back to a previous conversation or a previous sequence of conversations, the agent can refer back to the short-term memory and get the information back. But the long-term memory is about building some level of intelligence from your short-term memory. This kind of intelligence could be a personalization for a particular user. Imagine a scenario that I, as a user, I've been using this agent for, let's say, 10 days, and I've been asking a bunch of questions to this agent. And all these conversations are stored in the short-term memory. Now, this long-term memory, you could create a strategy to say that what is Mina's preferences or personalization, right? And you can create a strategy, and looking at all the short-term memory messages, this long-term memory extracts this information and creates a personalization for me, for the agent. So the next time I log into the agent goes back to the long-term memory and say, hey, tell me a little bit about Mina. What does he like? Where is he from? And all this other information. So, and then the way I interact with the agent is much more personalized rather than, agent talking to everyone in the same way. So that's where the long-term memory comes into play. And imagine this long-term memory is provided to you without you setting up anything, right? So that's where AgentCore memory comes into play. So in short, there are 5 different components of AgentCore: runtime to deploy, observability to observe everything that happens, identity to have a registry of all the agents that runs, a gateway through which it can access your enterprise differentiators, and a memory to manage your short-term and long-term memory. So what are the core differentiators? So I said it's a managed service. You didn't need to provision, scale, nothing. It's completely serverless in nature. You only pay for what you use, right? So only if the agent core is getting used, that's when you actually pay for it. So again, it's modular. We talked about 5 different components. Do you have to use all the 5 components? Absolutely not. If you like runtime, use runtime and don't worry about the rest of the components. Well, if you like memory, use memory and forget about the rest of the components. So it's completely independent of one another, modular in nature. Pick and choose what best works for you and your use case. Third, it's configurable and customizable. A lot of times we worry about black box implementations. In this case, AgentCore is completely configurable and customizable. Every component you can take it, configure it the way you want, customize the way you want, and there's much more coming up, right? So in terms of customizing it to your requirements, right? So that's a huge benefit when you think about these kind of managed service with the customization with it. We talked about pay-as-you-go model. So built-in security and built-in observability, right? Observability is built in for every component, not only for runtime. Anything that happens with memory, it's observed. Anything that happens with gateway, it's observed. Everything is into an OTel compatible observability capability that you can either use CloudWatch or push it into a third party if you choose to do so. Right? All of a sudden, the last mile where you started with a proof of concept, then went into prototyping, and the last mile of putting it into production and not worrying about it, this is where AgentCore shines. And this, given that this is completely agent framework agnostic, you can use it with any framework you want. Hopefully, this gives you a good understanding holistically of what an agent is, what are the key components of an agent, where does framework comes into play, what is a runtime, and where does AgentCore plays a role, what are the different components of the AgentCore, and what are the key differentiators. In the subsequent slides, what we'll do is we'll take one framework, let's say for example strands as a framework, start building agents with strands, and now take it and deploy it into AgentCore and use all the different components of AgentCore and see how each of them works in conjunction. Okay. Thank you very much for listening to the video and hope you have a great day.